I think we'll move on to the next doer, and that is Dr. Klassen. His research focuses on the impact of prenatal exposure to environmental pollutants. He's the Director of Public Health Research and Professor of Family, Population, and Preventive Medicine at the Renaissance School of Medicine at Stony Brook. I love that title, the Renaissance School of Medicine. I think his approach to understanding social determinants of population aging, his work with WTC responders focuses on understanding the association between exposures of World Trade Center and more rapid cognitive aging.
So today I'm going to talk a little bit about research that's ongoing. I'm going to start with talking about research that's been published and kind of build into things that are up and coming or coming this year and being done by our workers. Our general goal today is to understand some of the results that are coming on for neurological and neurodegenerative biomarkers, mostly in the blood, and looking at World Trade Center exposures in particular and a new rating scale for it that we've developed. And then talk about how these biomarkers do or do not fit existing profiles for conditions in older responders. We'll be mostly focusing on responders who were exposed during and after 9/11, but were exposed, many of them, for months, so this is a little bit different from some of the survivors, as they did the response. Of course, there are both physical and emotional costs and exposures here. I often focus on many of the emotional exposures. Today I'm going to talk more about the physical ones. This is an interesting study. It shows that fine particulate matter and neurotoxins can enter the brain. This can be found in children, as was similar to the last study, but it's also been found in older individuals. And it tends to elicit an Alzheimer's-like response. And so what does that look like? It can be two things. This is a nice little picture that we came up with explaining how some of the fine particulate matter has at least the potential to enter the brain through the intranasally and maybe cause an immune response in the frontal part of the brain. Of course, it could also be inhaled through the lungs, enter into the blood, and then go through the brainstem as well. This work is developing on symptoms work that has shown a reliable association between exposure, duration of exposure, exposure to dust, and increased incidence and prevalence of cognitive dysfunction. This is from a published paper from a couple of years ago where we showed that incidence of dementia was relatively high, and also that being there for longer than about 5 weeks was associated with a much higher risk of this, of cognitive dysfunction as scored by an AI program. All right, this is also when you're adjusting for usual lifestyle factors as well as PTSD, which is our other big risk factor in this cohort. We usually adjust for a variety of medical conditions. Of course, most of our responders are under the age of 65, so very many of them don't have the types of conditions that you think of when you think of cognitive dysfunction and dementia. Today, we're going to be talking about biomarkers that we measure in the blood, but are mostly expressed in the brain. This is a funny picture, a cartoon of a neuron, and you can sort of see different parts of it. I pulled it off the web. It can be damaged, and it's regularly damaged in Alzheimer's by amyloid plaques. These can sit anywhere, and they form as kind of diffuse plaques, and they become more and more senile or more dense over time. When they do that, they can cause changes in the neuron itself, including tau phosphorylation, which we can measure in the blood because the tau particles, they drop out of the brain and enter into the periphery. We also can damage the axon itself, releasing neurofilaments, and of course, glia regularly respond to this. We'll be talking a little bit about these particles. We mostly measure them in the blood, like I say, but you can also measure them in the brain if you want. What are our expectations? This becomes important as we go on. If people are going through this neurodegenerative process, like an Alzheimer's-like process, we would anticipate no change in amyloid 40. It's one of the particles we use as a reference region or reference category. We would experience or expect changes in the negative for amyloid 42. And then, of course, the ratio depends on which way you go. We're going to use the bottom one. So we should see increases in the amyloid 40 over 42 ratio. We should see more tau phosphorylation and more neurofilament light in the blood, as well as plausibly glial activation. If you look at imaging, you will then see the opposite for measures of anatomy, such as hippocampal volume or cortical thickness. You should see neurodegeneration. So I'm going to go through a couple of things of what we've seen. We'll start with imaging. This is a picture of hippocampal volume reductions that we found in our cognitively impaired subjects. We have quite a few of these people. And there are two remarkable things here. One is that this pattern is, we see sizable and statistically significant changes in hippocampal volume in our cognitively impaired individuals, but also that this particular signature doesn't line up with known conditions. Usually you see hippocampal atrophy in dementia, but you don't always see it in these parts, subparts of the hippocampus. When we took a look at correlations with standard phenotypes in our data other than cognitive impairment, we show the cognitive impairment site stuff. We found that it was associated with length of time working on the World Trade Center for dust-exposed responders who didn't use PPE. When we start looking at some of our blood work, I'll be mostly talking about this today, as we've transitioned from sort of imaging into more a widespread screening protocol. I'm going to mostly talk about these individuals. They're about mid-50s on average when we started sampling their blood. We operate a relatively large blood biobank. They're highly educated, mostly male, as you might imagine, the responders. Many of them are untrained or volunteer or construction working responders. They're not first responders like firefighters or NYPD, but most of them are NYPD for us. And a lot of them were exposed to the dust cloud, but many of them also worked a very long time on the ground. When we look at what types of phenotypes we see, it turns out we see quite a few. We do find quite a few people who have elevated levels of neurofilament light, phospho-tau, and amyloid 40 over 42 ratio. We use this ratio because, like I said, it goes up, so more of it is bad. Or it's thought to be bad in the Alzheimer's world, and we do find elevated levels of even amyloid positive, tau positive, and neurofilament positive individuals in our sample of around 1,000 individuals, responders. We also found an elevated number of people with tau positive and neurofilament positive phenotypes, which is a non-Alzheimer's sort of structure. That's the Alzheimer's Z1, and that's the non-Alzheimer's Z1, or supposedly. All right. When we took a look at what are predictors for these Alzheimer's-like phenotypes, we found that our biggest predictors were of tau phosphorylation and included length of time on site and whether or not people were doing manual labor or really not a supervisor, so they were on the ground. We've been refining our exposure phenotypes over time, so I'll talk a little bit more about that effort. Next, we also took a look at glial activation, which its relationship with Alzheimer's phenotypes is not super clear, I would say. It is more clear as to how it relates to stroke and cerebrovascular disease. Here, what we did is we excluded people who looked like they maybe had GFAP levels consistent with stroke, and we looked at everybody else. And in that group, we didn't find exposure effects, but we did find PTSD effects. Notably, PTSD was associated with lower glial activation as measured using GFAP. This is actually in contrast with some of our imaging results, which show higher levels, at least of, and plausibly higher levels of sort of macrophagic reactions, but we can talk about that later. Okay. Now, This is results from several mouse studies showing that World Trade Center exposures in mice are both identifiable in the brain and, interestingly enough, elicit this funny response here. So it may not look funny to you, but the one in the middle is unusual. So this is an elevation in amyloid 40. Like I said, we don't expect a lot of changes in amyloid 40. In the Alzheimer's space, we use this as the reference for how much amyloid is in the blood. It is, of course, an immune response marker, as is amyloid 42. But this, is an initial sign that maybe something is not going on or is going sort of differently than we might expect otherwise. You do see changes in the ratio as well. Yeah, okay. So we also do see some changes in the amyloid 40 over 40 or 42 over 40 ratio, but they're in a funny direction and inconsistent, I would say, or they did. So we started now moving forward into sort of the newer stuff. This work is mostly done by some of my research staff, Ryan and Alyssa. And here what we've got is that we started looking at that amyloid 40 levels as a result of some of this work, showing that exposure can be associated with changes in amyloid 40. This is an exposure severity ranking from a published paper. And here what we're finding is that for the most part, our minimally exposed individuals seem to have relatively standard amyloid 40 levels. But then any amount of exposure seems to be associated with an increase in this biomarker, which is unusual. It also makes it hard to use. So just in case you're interested, our minimally exposed groups are people who reported no dust exposure, reported using consistently and always using PPE, or including hazmat suits, or individuals who worked far away from the sites and didn't, and worked for short periods of time. When we take a look at that, like I say, amyloid 40 is supposed to be our reference category. So seeing this elevation was kind of a surprise, I would say. So we started looking at its correlations with other neurological phenotypes, and we found that there were both positive associations with amyloid 42, which is what you might expect here on the left. It's the darkest red. That's why we use it as a reference category. But also there are pathogenic or pathological indications that higher levels of amyloid 40 are also associated with higher levels of phosphorylated tau, which is our largest sort of predictor there, as well as the other immunogenic response, the glial acidic protein, and neurofilament light. When we took a look at some of the other ratios, we saw less, but they're a little bit more specious. On the right here, we have the association between, in our individuals who are neuroimaged, we have the association between higher levels of amyloid 40 and lower levels of cortical thickness, indicating at least potentially that it might act as a sort of biomarker for neurodegeneration as well. Sorry, I've got to lean forward a little bit if you want to hear me. All right, so that takes us back to the neurons and what's going on here. So when you take a look at what might be happening, I think one thing that's worth noting is that amyloid 40 does a couple of different things, but one specific thing that it does or can do is that it turns a diffuse plaque, a sort of milder plaque, into a dense plaque. That's its main goal. It is very sticky. And so that's kind of what we think may be happening here. Of course, it's also involved in several other vascular responses. So when we take a look at what we anticipated from the Alzheimer's sort of phenotyping world, we immediately found that the top line here is not true. We don't see that there isn't any change, and we therefore don't see that it can operate as a, at least for our responders, as a reference category or a reference phenotype. And so that was probably the most surprising part of this result for us. We also, as a result, can't trust the ratios. So, a lot of, building on the Alzheimer's world, we should be focusing on the ratios. Building on our data where the ratios aren't going to be useful for us. So moving forward, that's a problem in some ways, and it's a benefit in others. There's lots of course, future research needs that we need to, or future questions that we could understand here. So first off is, insofar as we're running this as a screening program, we hope to understand both the biology of World Trade Center related cognitive impairment, as well as, oh, I'm way under time, as well as the, that's good, as well as whether or not we can reliably use it to phenotype individuals who maybe have cognitive impairment. One of the struggles we have, of course, is that insofar as amyloid 40 is elevated in a lot of people, it is therefore difficult to use it to differentiate people who are cognitively impaired versus those who are not. But it may help to understand more about whether or not we can differentiate people who are exposed, and then maybe use some of these other factors to understand more about whether or not the exposure is associated with other types of neurological changes. So part of our goal with this study as we move forward will be to start to put those data together to see if we can't do some of that phenotyping. We also obviously don't know if there's one particular type of exposure or several types of exposures that might be related to these types of things. So I think in the future, some of the work, such as the one that we just saw, doing some phenotyping in the blood, to identify things like PFAS or dioxins may be really critically important, since we know that those are some of the exposures that we're interested in here. Also, the biggest, sort of factor here, whilst we were able to show that amyloid was associated with cortical thickness, which is the best measure of neurodegeneration out there, we do not know if that's because amyloidosis is creating some kind of runaway immune response, or if it's creating an amyloid like Alzheimer's or a tauopathy or something like that. So future research is going to talk a little bit more about that. Yeah, so that's what sort of the direction that we're taking. I, of course, want to acknowledge everyone, including the co-authors on the paper that I just described, and the students and many of the individuals here with whom we work. Sure.
Questions? I have a question, and that is, how are we close to any actual actionable measures that people can take to manage their cognitive health? How far away are we from that, based on your class?
Sure.
Easy question. Right?
Easy question.
Yeah.
Sure. Why not? I think we're far away. I've been struggling a bit with that question myself, to be honest with you. There are treatments available for amyloidosis now. It is claimed that they work, and I think the FDA has passed them. So there are some treatments available. There are lots of questions. So we know that those treatments don't work in tau and tauopathies. We also are fairly sure that they cause at least some side effects and brain damage. And so the risks and the benefits are, I think, for me, the risks are pretty heavy, and the benefits are fairly few. The biggest issue is that we need to understand more about whether or not tauopathy is there to know if they could even work at all. And same thing with amyloid. So without the imaging studies, I think we're at least a couple of years away from knowing that for sure. At least.
Thank you. Thank you, really interesting work. I was wondering, so, of course, sorry, I got distracted by the microphone. Anna Mullins, Mount Sinai. With cognitive impairment, I was, the match of the AD biomarkers with the trajectory of the disease, there's a little bit of a U-shape. I was wondering if in your cohort you have an idea about the relationship between where they're at with their AD biomarkers and where they're at with their cognition.
Sure. I didn't present it, I guess, but we have done some of the association studies for that. What we found is that they are generally associated with Biomarkers, it isn't as clean as you would like it to be. And so we found that it's a little bit better if you put them together, so evidence of biomarker changes on at least 2 of the biomarkers. We found that phosphorylated tau in particular is associated with cognition in these individuals, but the levels are relatively low in comparison to some of the Alzheimer's cohorts where these types of biomarkers were validated. So, and I think that's mostly because of the youth of the sample, right? Like I said, our guys are on average 55 or 57 in this study. They're getting older now, but they're still not in the 70 on average range that most of these biomarkers are used. So hopefully they perform better over time. I would also say that we were kind of sidetracked by using this ratio as compared to using the amyloid 40. You know, we did see this elevation, and actually our results, any ratio results we had were mostly explained by the fact that the ratio increased because amyloid 40 jumped, rather than because amyloid 42 went down, which is what we should have seen. And so my hope is in the next couple of years that we'll be able to refine sort of a phenotype for World Trade Center that works better than the current sort of raw data. Robert?
Yeah, Robert Brackbill, World Trade Center Health Registry. So we had the previous presentation of all the different chemicals, this and that, you know, that I've measured in the blood, et cetera. So, and when you talk about the exposure, you know, it's sort of this generic dust cloud or whatever, right? And how much dust. So what do you think in the dust cloud actually leads to these particular changes? You know, the appearance of these various things in the brain that end up with degeneration. So
Sure, it's a good question.
yeah,
It's one that I've been asking myself a lot, and I don't know. So the other thing I should point out is that for us and for a lot of our work, going way back, we mostly use exposure in terms of duration. How long were you exposed, rather than whether or not you were in the dust cloud. The reason that we do that is that, as far as we can tell, the dust cloud was made up of sharp, coarse particulate matter, and the research suggests that the dust on the ground, the settled dust or the re-aerosolized dust, was pulverized and burnt and refined, if you like, got smaller. And in order to make it into the brain, our working hypothesis is that it needs to be fine, small enough you can't see it, and it needs to be kind of round. So it needs to be refined or rolled over or something. And so we mostly focus on people reporting that kind of exposure and lengthy exposures to kind of get away from that dust cloud. And this has been important for us because we do have a lot of people who were heavily exposed to the dust cloud, but who then were sick enough that they weren't exposed to the rest, or they stopped working. And they can develop cognitive impairments, of course, but for us, that's actually not the bulk of our cases. The bulk of our cases is the cell dust. Now, having said that, it gives us some idea as to what maybe mechanisms might be. One thought we had was that a main mechanism might be that the dust is being inhaled and entering intranasally, and it's just settling in the brain. The brain isn't really adapted to deal with that. And so, as far as we can tell, there's nowhere to put that dust. There's nowhere to, your brain just can't deal with it. And so it just kind of sits there. One of the reasons we think that amyloid might be responding is that amyloid plays 2 roles. In the Alzheimer's world, it's the bad guy. But in the immune response world, it's actually kind of the good guy. It's part of the immune system, and its main job is to respond to one of its main jobs in the brain is to respond, as far as we can tell, to viral particles. And so, and keep you alive. So, mice that are injected with herpes virus, for example, if they can't produce amyloid, they die. And if they can produce amyloid, they live a longer and healthier life, but many of them get Alzheimer's. And so, so we're not sure if it's one particular chemical anyway, or if it's just any non-biologic particle that made it into the brain. And I think those are important questions to be asking going forward. Good question.
All right. Actually, I had another, you sort of let me think about another question.
Sure.
And that is that, I mean, the people in your study, I mean, some of them die. So maybe would you have access to their brains to actually look at, you know, whether there's dust and this and that?
It's a good question. You're right, many of them do die. We don't have yet a ton of people dying, but it's an important question. We do have an IRB up and running for such a thing, but we haven't yet collected any brains to that order. We do think it would be important. One of the things you can do these days, if you do have brains, is identify the dust itself, if it's there. So, okay.
Can I?
Nice to see you from Florida.
Okay, great. Thank you, Sean. Roberto Lucchini, Florida International University. Sean, don't be, I guess, we've been talking about this, but you know, the fact that you see the beta amyloid 40 behaving differently, it doesn't bother me that much, quite honestly, because for different reasons, you know, there are different studies showing this types of behavior, first of all. Second, you know, that these two beta amyloid 40 and 42, they are just two out of many other parameters and proteins into the mechanistic scenario. So we probably should focus also on other related pieces of this puzzle. But of course, these are the first ones. So, but I think it's also nice to see how that relates to the cortical thickness. That's, to me, it's even more telling the story rather than being concerned about is this usual or not. And also, I think we should not forget that this is kind of a unique type of exposure and situation. So, I guess, what's your comment?
I agree with you. Originally, we saw this while we were writing the paper on phosphorylated tau, but you know, reviewers pushed us into looking at the ratio, and so we felt like maybe it was important to do this secondary study to looking at why amyloid 40 is elevated and whether or not that's a problem, right? The general rule or the general view in this literature is that it's probably not a problem. You know, amyloid 40 is just normal, and so I think it does behoove us to say it's not just normal. Like, there's a reason that it sometimes is elevated, and it's interesting for us because it may help us to understand some of that exposure effect. And we need more help, I think, figuring out who to focus on. So we were kind of seeing it in that light as well. But I agree with you. Ultimately, we are, you know, when we've done studies in the past of proteomics in CI, looking sort of at a broader array, we do find that different proteomes and different types of omics display different types of results, I would say, and some of them are more or less sensitive to the outcome. I think they're just less well established, and so these are the established ones, and as we develop a good sense of how they work, I think will be easier to then bring in the less established ones and say, this is how these work, you know, or this is what they're telling us. Great question.
We have about 1 minute. Your question, identify yourself, please.
Yong Zhao Sao from NYU. Great talk, Sean. I just wonder whether you look at any direct link with cognitive measures like a MoCA or?
Yeah, sure. So we do find associations. What's worth saying here? We find associations. Part of what we're trying to do is also isolate whether or not we can say whether or not a person, as they get older, you know, there's a question that is critically important as people get older, which is who of these people doesn't have World Trade Center, you know, cognitive issues. And so we've done that in a couple of different ways. One is that we developed an algorithm for putting together the cognitive data and linking it to things like exposure. So that's that first data set I showed you. And as it turns out, this is very helpful because the cognitive data that we generally use is really targeted at Alzheimer's disease for the most part, right? We use this measure, you know, we use episodic memory a lot because it's really targeted. What we found in our own studies is that for the cognitive, or for the World Trade Center responders, the range of cognitive dysfunction is much larger. So the phenotype doesn't actually fit Alzheimer's. And so part of what we're trying to understand is a little bit more of how do we differentiate these types of conditions and what does that tell us about what's going on. Anyway, well, your main question was about cognition. The answer is generically, yes, they're associated with cognition in the way that you would anticipate them to be, except for amyloid 40. And B, we're not sure. But B, they're not as strongly associated as you would see end of life in Alzheimer's patients as compared to non-Alzheimer's. So we're trying to tease that apart.
Thank you.
Yeah, of course.
Our next doer is Dr. Mann, and he has developed an expertise in quantitative genetics and applied statistics, including structural equations and modeling and item response theory. In the fall of 2020, he began working at Stony Brook, Department of Family, Population, and Preventive Medicine. To date, he has authored over 50 peer-reviewed scientific articles, which have accrued over 1,700 citations. Today, he will be presenting his study findings from his collaborative efforts of investigating Stony Brook and the health clinic and the New York City Fire Department responders. Dr. Mann.
Thank you. So wonderful to see so many of you in person. So today I'm going to be talking about the prevalence of cognitive impairment that we see in our World Trade Center exposed members of the FDNY in comparison to the prevalence estimates we see in our general responders at Stony Brook. And this is a preliminary report of our initial findings. We have our first manuscript that's in preparation. It will be very soon submitted for peer review, and a number of other data analyses underway. So we're just going to kind of be scratching the surface with the work that's ongoing here. And of course, the results here are presented by myself, but none of this work would be possible without the wealth of material and intellectual and financial support that's provided by Dr. Luft and the World Trade Center Health Program, and Dr. Prezant and Dr. Clouston and all of our collaborators at the FDNY. So thank you all. So for a sort of quick summary of what we know from our team's past and recent work, and what sort of served as a springboard for the investigation that I'm going to be presenting, is that we see a high incidence of mild cognitive impairment, MCI, and early and onset dementia in our general responder cohort, right, which includes our responders who were not members of the FDNY on 9/11, and they consist mostly of law enforcement, construction workers, and civilian volunteers. And for the purpose of brevity, we'll refer to them as our GRC, or general responders. So in addition to documenting a high incidence of MCI and early onset dementia, we've also found evidence for the central role of long-term exposures to fine particulate matter in our general responders. And while these responders were exposed to a number of known pollutants that we've heard about earlier today, they may have been exposed to different types of particulate matter and for different lengths of time as compared to members of the FDNY. So in terms of our motivation for screening for MCI and possible dementia or a major neurocognitive disorder in members of the FDNY, it's really a critical time to start to examine prevalence in our FDNY responders, since of course it's well documented that the less severely but often more chronically exposed responders from the general responder cohort are developing MCI and early onset dementia, making examination and characterization and firefighters timely. So we wanted to go ahead and screen for MCI, possible dementia, in a large or moderate sample of our World Trade Center exposed FDNY responders. And this is, of course, not only gives us insight into the levels of cognitive impairment in our firefighters, but also enables a test of a sort of out of sample replication for the high levels of impairment that we've observed in our general responder cohort. So in terms of our next steps, we had a couple of goals in mind. First, of course, is to determine whether the FDNY and the general responders differ in their prevalence of MCI, as well as more severe cognitive impairments that are indicative of possible dementia. In the past, in the general responder cohort, we've relied heavily on the MoCA to screen for MCI and possible dementia. And with our firefighters, we wanted to administer even a broader range of cognitive assessments that kind of drill down into domain-specific deficits to enable, among other things, like examining domain-specific deficits and correlates, but to examine different operational definitions of MCI to see how this may impact our prevalence estimates. So in the past, we've operationalized MCI using the MoCA, which is a great assessment. It's age sensitive. It includes 12 different subtests that are all essentially shortened versions of various tests of memory and executive function that are used to screen commonly for MCI and dementia. But they're sort of abbreviated or shortened versions of all of these tests. So for this study of cognitive impairment in the firefighters, we administered a broader range of assessments that provide greater fidelity about domain-specific deficits and also allows us to operationalize MCI using different sort of canonical algorithmic routines or operational definitions for MCI, including Jack-Bondi criteria, Peterson criteria, and NIA criteria. So we can see how much the operational definition of MCI is impacting the prevalence estimates. And then to help determine clinical significance, we wanted to compare the prevalence estimates that we see in the FDNY and in our general responders to meta-analytic estimates of MCI and early onset dementia from different global community and clinical populations. This is, again, to try to contextualize the levels of cognitive impairment and how clinically significant they really are. That's something we hear often from colleagues and reviewers is, we see high levels of MCI, sure, but people will say, well, MCI is really common in aging cohorts. So, how high are your levels? Are they really clinically significant? And then finally, we wanted to sort of thoroughly characterize the domain-specific deficits of our cognitively impaired responders in the FDNY by, again, analyzing scores from a larger battery of objective neurocognitive tests. So in terms of enrollment criteria for participating in our study, we focused on individuals who are 45 to 69 years old, so under 70, obviously capacity to provide informed consent and then willingness to travel to SBU. There's also a subsample of folks from this study were funneled into a PET MRI imaging study. So some of the inclusion criteria are included for that component of the study as well. And we also excluded individuals with a history of stroke, history of serious head trauma, benign brain tumors, brain cancer, unmanaged diabetes, and so on. Some of the sort of candidate health factors that one might expect to lead to cognitive impairment, and those were excluded. So here's a table reporting the sample characteristics. I probably should have a slide or two here dedicated to participant recruitment and enrollment and data collection. This was a very extensive and collaborative effort between our laboratory coordinators at SBU and our collaborators at the FDNY. And a lot of work was actually done into ensuring that our sample characteristics match that of the source population for the FDNY, particularly with respect to PTSD symptoms and subjective cognitive concerns as measured by the CFI. So what we initially did was we would identify in batches of 100 FDNY responders who met the inclusion criteria. We went out and sent out in batches of 100 letters, invitations to participate in the study. Those were then followed up with phone calls to try to further recruit people. And this process of random sampling kind of transformed into stratified random sampling as we went on, and we would check to see whether or not the PCLs and the CFIs for the recruited subjects were representative of the greater FDNY source population. And we ended up resulting in the sample that you see reported here, that in terms of PCLs and the CFI and overarching demographic characteristics does a really nice job of capturing that source population. So you'll see here on the left, in terms of our World Trade Center exposed FDNY responders, our target sample size was 300. We exceeded that, ended up recruiting 343 through that stratified random sampling. We also actually recruited another 40 or so through referrals. Those were excluded from these initial analyses. We have run some assessments of the referrals. They actually don't, the referrals don't have worse objective cognitive functioning. They have higher subjective cognitive concerns and higher PTSD symptoms, but actually not worse objective cognitive function. But I digress. Those referrals were excluded from the purposes of our analyses today. But you can see, the average age was about 60 years old, predominantly male, predominantly white. You can see the education and occupational breakdowns there, and our county of residence, the majority were residing in either Suffolk or Nassau County. And then the other two panels to the right there, that's our World Trade Center exposed general responder cohort. We tried a couple of different comparison cohorts for period prevalence of MCI and more severe impairments. We ended up, it doesn't really change at all the substantive scientific conclusions of the analysis. We ended up deciding on selecting all of the World Trade Center responders who completed a MOCA during the same observational window as the study was conducted for the FDNY, so that when we're comparing period prevalence, it's literally a comparison of period prevalence over the same calendar dates. So that's how we ended up with the 7,102 responders for our comparison cohort. So next we have here not only the descriptive statistics for our focal study variables, but also a list there of what those variables were, what the measures were. So we have the MOCA, which is our sort of primary assessment of cognitive impairment that I just previously described. We administered the SPPB, so this is a measure of lower extremity function, maximal hand grip strength to assess fragility. Then we have the Hopkins Verbal Learning Test, the total recall, delayed recall, the recognition and retention subtests of the Hopkins Verbal Learning Test. We have the Boston Naming Task. We have the RAT4 reading to assess general cognition, trail making A and B to assess psychomotor speed and choice reaction speed, the symbol digit modalities test to assess working memory, the COA to assess verbal fluency. Then we also administered the Cog State, which is a subset of computerized assessments that are game-like and from which you can derive measures of episodic memory, visual working memory, reaction speed, processing speed, cognitive throughput, visual spatial function, and working memory. And then finally, we have self-report measures. We have PHQ-9 for depressive symptoms and the CFI to assess subjective cognitive concerns. So thinking about specific aims, focusing on this first one here, so to determine whether the FDNY and the general responders differ in their prevalence of MCI as well as more severe impairments indicative of possible dementia. We ran some fairly straightforward generalized linear models, testing our cohort differences in cognitive impairment, using logistic regression for the more severe impairments indicative of possible dementia. That's a comparatively rare outcome, and using Poisson regression with a sandwich estimator to account for the fact that the mean and variance are unequal and get robust standard errors for MCI because it's a more common outcome. And of course, odds ratios and risk ratios approximate one another when outcomes are rare, but when they're more common, the odds ratios start to float away from the relative risk ratios. So the relative risk ratios for more common outcomes is a more conservative estimate or a more conservative effect size. So what we see here is that using the general responder cohort as the sort of reference group, our FDNY responders are showing an increased risk of MCI determined using the MoCA. And they're, in terms of the crude prevalence rates, they're actually showing slightly lower levels of more severe impairments indicative of possible dementia compared to the general responders, but those differences are not statistically significant. So we see no statistically significant difference between the general responders and the FDNY and the more severe impairments. But when looking at MCI, we do find that it's more common among our FDNY responders than our general responders. So moving on now to think about how, the operational definition of MCI might impact our estimates of period prevalence and to help determine clinical significance, we can start breaking down our crude prevalence rates of MCI and possible dementia using various diagnostic routines. So I have them broken down here in this table, not only according to whether or not they're FDNY responders or general responders, but also whether it's the entire cohort or whether we've restricted it to just responders who are under 65 years old. Right? This is because very often 65 years old is used as a cutoff to denote early onset of impairments. Obviously, when we have high prevalence and it's early onset, it's not going to be attributable to many of the sort of age-related causes of impairments that we tend to see, but would be more likely indicative of a World Trade Center-related exposure effect. So if we start at the top panel with the FDNY responders, we can look at the Jack Bondi, Peterson, and NIA criteria for MCI, and you can see that the crude prevalence rates are quite similar. I mean, they're ranging from about 52% to 58%. Now, comparing that to the MoCA within the FDNY, we have two sets of cutoffs. We have the 19 to 26 cutoff you see there. That's the cutoff that's outlined in the code book. When using the sort of liberal code book defined cutoff for MCI, determined using the MoCA, we actually see the prevalence rate jump even higher, up to 68%. When we use a more conservative MoCA cutoff that we actually have been using in our past studies of incidence and the general responders, it's actually a bit lower than the sort of canonical definitions of MCI that we see that are commonly used in literature. And then finally, for possible dementia, we only have about 14 cases, about 4%. Although this doesn't strike us, I think, most intuitively as especially high. I mean, if we look at the next panel down then in responders who are under 65 years old, it's about 3%, only 8 cases. This might not seem alarming, but the next couple of figures will drive home just how uncommon severe impairments indicative of dementia are before the age of 65. I mean, really, if you have 1 or 2 cases out of 300, that would be quite high if you're looking at folks who are just under 65 years old. So again, we have the same prevalence estimates broken down under 65 years old, not a huge change. And then we have the same prevalence estimates broken down for the general responders, but perhaps this next figure is a little bit more illuminating than that big table full of numbers there. So here we have our prevalence estimates by this in the FDNY according to those sort of canonical definitions, Jack Bondi, Peterson, and so on. And then we have the estimates of MCI prevalence for the FDNY responders as determined using the MoCA, and then the SBU responders for whom we just have the MoCA on. And of course, this is a forwards plot. This is the number estimated cases for 100 individuals at risk. So these are percentages. The square is the point estimate. The horizontal line is the 95% confidence interval going around that. And I created this figure not only to have a visualization of the prevalence estimate that we see in the FDNY and with our general responders, but to compare that to the prevalence that we see in meta-analyses of different community, clinical, and sort of global populations. So the study, first author and year is here on the left, and then we have a sort of a description of the sample that was meta-analyzed for prevalence of MCI. So you can see here that we have community samples, right, just broadly for folks who are over 50 years old. Then right below that in gray, we have patients with Parkinson's disease, individuals or residents of nursing homes, clinic samples, and then goes down. We had a couple of meta-analyses that actually distinguished whether Peterson or NIAA criteria were used, or whether subjective complaints and objective tests were used in combination or just objective tests. Then we have some clinical samples there. So individual samples and clinic samples with hypertension. We have patients the first year after strokes. We have patients with HIV, patients with during chemotherapy, breast cancer patients during chemotherapy. And I think what's evident here is, so the only meta-analytic estimate that is not significantly lower than the prevalence estimates we're seeing for our responders is the clinic samples with hypertension. You can see there that the crude period prevalence estimate actually is lower, but there were so few studies included in that meta-analysis, you have those really wide confidence intervals that are overlapping with our margins of error. But with that exception of the clinic samples with hypertension, the crude prevalence estimates in our responders are significantly higher than all of these meta-analytic estimates of the prevalence of MCI across all of these different community clinical samples. So that is to say, how high is MCI in our cohort? Well, it's higher than we see with breast cancer patients who are undergoing chemotherapy. It's higher than we see in patients with Parkinson's disease. It's higher in patients the first year after they're recovering from a stroke. It's higher than what we see in residents of nursing homes. So that high. So here's the same figure, except this is, of course, now the prevalence of severe cognitive impairments indicative of a possible dementia or a major neurocognitive disorder in our World Trade Center responders who are under 65 years old. Of course, the orange estimates at the top are the ones from our cohorts, either SBU, all the World Trade Center responders, combining SBU, general responders in the FDNY or the FDNY. And then all those gray estimates we see kind of jumping around here at the left side of the figure, those are either meta-analytic estimates of early onset dementia from different world populations, or they're extraordinarily large cohort studies of dementia prevalence that included like 500,000 people, say, from Norway, or wasn't quite a meta-analysis, but still nonetheless seemed representative. So this figure is a visualization of kind of what I was emphasizing about how uncommon early onset dementia is, right? So you really don't see severe impairments before the age of 65. When you do, they're incredibly uncommon, always considerably less than 1%. So the fact that we're seeing more severe impairments that could be indicative of possible dementia in the range of, say, 3 to 6% actually is quite high, even though in some absolute sense, 3 to 6% might not seem like a lot. When you think about that in the context of, well, how common are severe impairments before the age of 65, right? They're seemingly uncommon. So against that backdrop, it's actually quite high. So then finally, we wanted to more thoroughly characterize the sort of domain-specific deficits of our cognitively impaired FDNY responders. So we can not only use all those domain-specific tests to use these different sort of algorithmic routines to have different operational definitions of MCI, but then we can also take, once we've categorized our responders or impaired or unimpaired on one particular instrument, say the MoCA, then we can sort of look at what the domain-specific profile looks like for those cognitively impaired responders across all of those domain-specific assessments. And this is what the general pattern of findings looks like. So right here in panel A and panel B, we have plotted standardized multiple regression coefficients that are adjusted for age. The top panel are our correlates of MCI. The bottom panel are our correlates of possible dementia. The first two here, SPPP and max grip strength, you can see that both for MCI and possible dementia, the dashed horizontal line is indicating 0, so anytime the 95% confidence intervals are overlapping with that dashed line, it's not going to be nominally significant at 0.05. So we can see that SPPP and grip strength not significantly higher or lower for our impaired responders as compared to the non-impaired responders. But what we do see is pretty widespread deficits across verbal and working memory as captured by the Hopkins Verbal Learning Task. We see deficits in the Boston Naming Task, which is startling and quite severe. We do see slightly lower levels of rat reading, decreased processing speed as measured by the trail making test. And then we can also see that we have lower episodic memory, lower working memory as measured by our computerized Cogstate assessments. And then finally, no significant association with the PHQ or CFI after adjustment for age. So that was also one of our interesting findings, is that right across the board, looking at pairwise associations or multivariable associations, that are the subjective reports of cognitive complaints were essentially unrelated to objective measures of cognitive function. There were weak associations, sort of in the magnitude of like 0.1, 0.15 sort of correlation, but CFI was correlated at 0.68, I believe it was, with depressive symptoms, right? So when we have our responders coming in with a lot of subjective cognitive concerns, there's actually a much greater likelihood that they're suffering from depression than they're actually suffering from objective deficits and cognition. But nevertheless, we see this sort of widespread, diffuse impairments across domains of memory and executive function. So now that I'm officially out of time, just to summarize our findings quickly, we have prevalence of MCI. It is significantly higher among our FDNY responders compared to the general responders, but the FDNY and general responders don't significantly differ in their prevalence of possible dementia. The operational definition of MCI had relatively little impact on the prevalence estimates, and using a conservative MoCA cutoff to define MCI was actually the exception, and it really resulted in a significantly lower prevalence estimate compared to our alternative definitions. Both MCI and more severe impairments are higher than meta-analytic estimates of MCI and early onset dementia that we see from different community and clinical populations. And the cognitive impairments of FDNY responders are characterized by pronounced deficits in verbal learning, verbal memory, and episodic memory, but also a number of executive functions like visual search, processing speed, attentional shifting, and mental flexibility. Thank you all for your time and attention, and thank you to the funders and all of my mentors and collaborators.
Sure. Questions for Dr. Mann? I have a similar question, the one that I had for Sean, and that is, are we at a point where we can recommend, educational interventions or system interventions at this point for responders?
So intervention, so I generally think of interventions or treatment strategies for MCI and early onset dementia as falling into a limited number of categories, right? We have our behavioral interventions, which are kind of focused on personalized strategies to increase socialization, and then diet and exercise. We have sort of physical therapy interventions that are focused on improving or maintaining balance and mobility. We have nursing interventions that are kind of focused on creating and maintaining a healthy home environment, making sure that patients develop healthy routines, stick to those routines, stick to their medications. And then we have a whole bunch of psychosocial interventions. So these are things like music therapy and art therapy and horticultural therapy and animal-assisted therapy and et cetera, and so on. So in my humble opinion, and from my reading of the intervention literature, is that broadly speaking, the most interventions are those that fall within the behavioral camp, usually diet, exercise, and socialization. That is by no means specific to World Trade Center responders. But the NIA and the Alzheimer's Association does have sort of these personalized workshops that they do with different special populations to try to develop effective community-based and sort of social relational-based interventions. I don't know if we're quite there yet. Yeah, and my understanding is that there's fairly limited evidence for the effectiveness of any of the other non-pharmacological interventions that I just mentioned. Yeah, I guess that's my thoughts on
That why question.
yeah.
Rob.
Frank, thank you for inspiring talk. It even inspired me to walk all the way up here, which I would rarely do. And I'm excited that the study was designed to include rat, because rat reading, conventionally used as a measure of premorbid intelligence, so anchoring this current neuropsychological profile to what presumably cognitive functioning was before 9/11. So what is the size of deficit on rat reading for the sample relative to norms?
If I remember correctly, it's in the ballpark of, it's less than half of a standard deviation. I think it's like around, in terms of like a standardized regression coefficient, we're talking like 0.25, like a standardized mean difference.
Yeah, so if you treat, let's say, general population score on rat reading as 100, standard deviation of 1, and just so it's available for the tests. So subtract mean of the sample, well, convert it basically to standardized metric on rat reading. Anyway, it's not of academic interest. I think it's very practical interest in the sense that you can be adjusting these comparisons, certainly the deficits for deficits on rat reading, assuming that these predate 9/11 exposures, to attribute what you see to actual decline, basically estimating actual decline.
Yeah, thanks, Roman. Yeah.
Take out Ben before we get to you. Let's take this question over here. Go
Hi,
ahead.
Alejandro Sofeifa, NIH, great presentation. I'm sorry to take you to table 1 of your presentation on the general responder cohort, which is a very robust cohort that you showed. Can you speak about the occupation, about the and the category of others, which is the 2,000 people there? Who are these people? And
yeah, so that's great. And I should have mentioned something else, which is that we had recruited in our FDNY study one of our, I think they were a referral anyways, they were excluded, but we had one individual who was NYPD at 9/11 and then transitioned to the FDNY afterwards. And then we actually do have a small number of individuals in the SBU general responder cohort who were firefighters at the time 11, and for the sake of the comparison, those responders were excluded from the general responder cohort. So when you see the big zeros for the firefighters and the general responders, that was by design. We actually do have a handful of them. So yeah, so the other, it's a lot. There's so many different occupations that when you start generating frequency tables, you start getting in so many categories that have 1% or less, which is why I grouped them all together as others. But I mean, we had like people like journalists would have been included in here that were down and were exposed to the disaster. Anybody journalists, publicists. I'm racking my brain trying to think of the other occupational codes that I grouped together there for other. A lot of like, these would have been, did I separate out construction workers there? Yeah, all right, so our construction workers are there. EMS, firefighters.
There were a lot of volunteers.
But yeah.
And they could be professional athletes. They could be journalists. They could be secretaries. They could be, it just, there were many, many people who went down there who just volunteered, citizen volunteers.
Ben?
Yeah, I
It's
just
already
want,
got the floor, so.
yes, I just wanted to mention, those were two fantastic talks, and I think that they're something that really moves the ball forward for this program. I just wanted to mention one thing about intervention, since, I'm on the clinical side. We see these people. When you talk about 4% of people that have dementia, you're talking about an extremely severe clinical situation, and where families are falling apart, and that there's a tremendous amount of service. So the interventions that are needed is really, it's like dealing with severe cases of Alzheimer's or significant cases of Alzheimer's, and we've all experienced that. The other thing I wanted to mention, and I think maybe this is something that needs to be addressed programmatically, this is something that is going to continue to increase, and I think that's evident by the MCI data that's been presented and what we can possibly predict what's going to happen in the future. However, this is a unique situation, a unique condition, and interventions that are needed, perhaps some of the interventions that we use for Alzheimer's may be useful, they might not be useful, they might actually be detrimental, but that will only be known by doing careful trials. And it's something that, this program has supported and developed this body of research. And this might be a new area that needs to be thought of programmatically, to do these type of trials and to see how we can intervene. This is a first timer, and so it's great to have a very solid body of knowledge to be able to base doing clinical trials with conviction.
One more question. We're a little bit over, but we're pushing our next speaker. So, Robert, if you can give us a 2-minute, we'll be fine.
Well, I'm not going to give a speech. I just have a question. Good to meet you, Frank. On team or whatever. Yeah. So, like when you mentioned journalists, it kind of made me think about the percentage of people who had a college degree. I think among the firefighters, and so. Have you looked at, education? I mean, sort of the cognitive reserve sort of thing, and, that kind of, which might have had some sort of factor or lessen the MCI you were seeing.
Yeah, we've obviously done far more analyses than what I was able to present today. And yeah, I was struck by how little educational attainment predictive differential functioning among firefighters. I mean, there could be a sort of ceiling effect here, right? Where like the selection process of becoming a firefighter has weeded out all the really low levels of educational attainment. So then you have range restriction and you don't really see much of an effect of your generalized linear models trying to predict these things from demographic characteristics. I mean, really the only reliable predictor that we saw was age. And educational attainment didn't do much.
Okay. All right. Oh, thank you.
Thanks. Our last speaker before lunch, and we'll grant him an extra 3 minutes for his talk, is a life scientist with a diverse expertise in neurosciences, ranging from molecular world. He is currently investigating the intricate factors and mechanisms underlying dementia and PTSD. He's currently investigating World Trade Center 9/11 exposed responders, now at midlife, who endured acute and chronic physical psychiatric injuries ranging from ranging from dust inhalations to intense emotional trauma.
Thank you for having me today. It's an honor to be here amongst you. Today we're going to talk a little bit about neuroinflammation, for it is an outcome we expect in this population, whether it's because of the dust exposures or whether it's because of the chronic stress that individuals with post-traumatic stress disorder are experiencing. So we're very interested in measuring the levels of neuroinflammation in our responder cohort. And I'm going to talk to you a little bit about those efforts today. So our responders, like I said, were exposed to toxic dust, severe trauma for prolonged periods of time, and that we have studies that report that the variable of a World Trade Center site exposure duration, how long they were there, is associated with peripheral markers of inflammation and is associated with a higher risk for developing this early onset form of dementia. And just to clarify, by early onset, we're talking about clinical cutoff of less than 65. So I'm going to talk a little bit about this measure called free water fraction, which measures water movement in vivo in the brain during an MRI. And it's a marker that is associated with neuroinflammation amongst other physiological processes. But it is a great way to gauge at level of neuroinflammation. However, before we get into that, we need to do some history. So where did we come from and why are we using free water fraction as a measure of neuroinflammation? Well, a few years ago, we tried to do a very ambitious PET-MR study, and we succeeded in it, but it was very, very difficult. What we did was, and this was before my time, I speak we as a team, but the PET radioligand FEPA is a biomarker for TSPO, which is a marker for glial activation, which is a marker for neuroinflammation. So we're extrapolating knock-on physiological effects here. So by measuring FEPA in vivo, you can gauge at levels of neuroinflammation. So this study was very grueling, very burdensome, and very difficult to perform. And I mention this on purpose because it will lead to what we're doing, what we did next. Just to give you an idea, the patient, subject, the responder needed to sit in the PET-MR for approximately 2 hours, lying still in the donut with an arterial line, which is a burdensome experience and not clinically that practical. However, it's a very powerful research tool. And what we found was that higher levels of FEPA were associated with total months on the World Trade Center site, so our duration exposure. And it showed a regional increase as well, so that more time at the World Trade Center site was associated with more FEPA at the frontal and parietal cortices, and it approached significance in the occipital, visual cortex on the back, and also there was a whole brain neuroinflammatory signal. So this was our first evidence really in vivo measuring in the brain whereby we could visualize a higher level of neuroinflammation in these responders that did associate with our variable of exposure duration. So the limitations of that study, like I mentioned, was how difficult it was to perform. And therefore we started looking at these other ways to assess and quantify levels of neuroinflammation in our population. And this brings us here to the free water fraction. So the population we're discussing here are 99 World Trade Center responders who were imaged at Mount Sinai. And the protocol for the MRI had sequences built into it that were specifically designed to gauge at the movement of free water. We stratified the sample into cognitively unimpaired and those with probable early onset dementia. The two groups did not differ on any of the characteristics. We controlled for PTSD. We matched on all these demographics, and the only difference was the cognitive status. Now, this DTI measure, free water fraction, has been, like I said previously, shown to estimate how much underlying neuroinflammation there might be in vivo in an individual. And I made a little diagram there just to essentially show you how this works. If water moves out of the cell more freely, then the cellular compartment, the membrane, the axon, all the things that are in biological place is compromised, therefore allowing more water to move freely in and out into the interstitial tissues, back into the neuron. So, and neuroinflammation as a process brings in water. So we can measure this in vivo a lot less difficult to do this than the PET MR. So let's talk about some results. So what this study found was that, once again, exposure duration was associated with an increase in this free water fraction, this measure of movement of water. And when we looked at an atlas of brain regions, the Desikan Atlas, Kiliani, we could pinpoint which specific regions of the brain demonstrated this increase of neuroinflammation. And we split them up into their respective lobes, because when you get the atlas, it comes out randomly with a region. So we made an effort to split it into its respective lobes so that we can talk about where these effects are localized. But in a general sense, as you can see, they seem to be localized in a global cortical fashion, whereby you see effects in frontal, limbic, temporal, parietal, and so on. And some key regions emerge that you might recognize, like the entorhinal cortex, which is a very high-risk area of the brain, that is one of the first areas of the brain to degenerate during Alzheimer's. And it's used as a biomarker. And indeed, in this study, we found that this measure of neuroinflammation is increased with, it shows increases in this region of the brain. And you can see other associated structures in the temporal lobe and the limbic. So, excuse me, this was some good evidence that this measure, that is so much easier to obtain than PET-MR, and more clinically useful in MRI studies, is picking up effects, significant effects in our population. When we looked more closely to plot some of these significant relationships, you can see here 3 graphs. We show the hippocampus shows a significant moderate correlation with free water fraction, suggesting that neuroinflammation is higher in this region. In the middle, we have cerebral white matter and cerebral gray matter. And we looked at these as a global measure. Also because of its clinical utility, it's far easier to look at the global levels of a brain signal than it is to parcellate into regions and then go analyze them one by one. So we wanted to look at global inflammation in the brain. And whilst the significance was, it was significant in cerebral white matter, it wasn't in gray matter. That might be a power issue, but it did trend upwards. Also, through our associational analysis of other demographic variables in the sample, we did find that apolipoprotein epsilon 4, which is a gene that puts individuals at higher risk for developing Alzheimer's, was also showing a significant association with the measure of neuroinflammation, insofar that if you had it, there was more neuroinflammation. In the paper, we also conducted a connectometry analysis to look at correlational tractography within regions of interest. And in a nutshell, it essentially confirms our previous findings as well, that it shows that the connectome is also showing signals associated with higher neuroinflammation, which is associated with site exposure duration. So what is the impact of this? Well, taken collectively with the PETMR study and this free water fraction study, we can provide evidence that the World Trade Center site exposure seems to be demonstrating a neuroinflammatory effect in our population, insofar that it is associating with key regions involved with cognitive impairments, such as limbic and temporal regions, but also other regions around the brain. It also showed us that in the hippocampus, for example, a key area, there was a moderately strong correlation, that we could also pick up on white matter inflammation on a global level with this technique, and as expected, possessing the apolipoprotein epsilon 4 gene made things worse. So what does this mean? It means that free water fraction as a sequence, as a technique, can serve as a biomarker. That's a lot easier to perform experimentally than a long, burdensome PETMRs, but they have different benefits. They have molecular resolution. On a research level, they're invaluable. But in terms of clinically translating techniques, that's a bigger challenge to do a PETMR in a clinical population as a routine measure of following people up, for example. Whereas something like free water fraction is not a long sequence. It takes 20 to 30 minutes, depending, and a simple MRI would suffice. And that, as a measure, we confirm from the literature that it is associated with neuroinflammation, and we do pick it up in our population. So, where do we go from here? Well, there is a need to further examine what free water fraction is associated with. For example, in the study I just talked about, we used the exposure variable duration. However, as you've seen from the talks this morning, since this study, our team has developed far more sophisticated measures of capturing World Trade Center exposure. You've seen figures of ordering the severity, categorizing the types of activities that responders carried out on site. So there exists a need for us to go back and explore which ones of these activities shows effects that are significantly associated with neuroinflammation. So there needs to be that study. We need to disentangle further who these people who are experiencing higher neuroinflammatory states are. Also, Sean alluded to a study where we looked at plasma, GFAP, which is a marker of neuroinflammation in the periphery. And instead, we found the opposite result there. So that means there needs to be another study that tries to disentangle why. Why is the plasma marker down when the brain marker is up? Is that how things behave? What is the molecular biology? So a study that does this associational analysis would be very helpful for us to understand the mechanisms that are underlying this process. And furthermore, and as Paul will talk next in the PETMR studies, we are still collecting valuable molecular information about a subset of our responders, particularly amyloid and tau, like you've heard from before. So there exists a need to study the association of those molecular markers with neuroinflammation to disentangle mechanisms. And of course, there's a whole plethora of other structural measures of the brain that we could explore, such as cortical thickness. And I use the word explore a lot because though we do approach this as a priori as possible, we are dealing with a population with an unknown encephalopathy. So there is an element of exploring possibly other measures so that we can further understand this process that the responders are going through. So I'm a bit early, But that gives us time for questions. I'd like to thank all these people, and I'd like to thank you for your attention. Thank you.
Questions? I have the same question, I guess, I've been asking our previous speakers.
I don't know if I know any more intervention mechanisms than what was said.
Is there a pathway? Do you see a pathway at some point?
I see a pathway where we start following these people longitudinally. Sorry. I see a pathway where we start following these people longitudinally, and we start monitoring all kinds of biomarkers that we've established are associated with this population. So I'm speaking in a general sense, and I think intervention mechanisms will be appropriated when we know more how these people are progressing. As for example, when we do longitudinal studies, we will be able to isolate who is accelerating more, who is more stable. That will inform intervention strategies and so much more. I mean, we really need we've so far taken many cross-sections of this population, and we really need to start thinking longitudinally about following these people, measuring their brain, measuring their plasma, measuring their cognition and their behavior and their motor symptoms, and where we can start building this picture of who is accelerating more, why are they accelerating more, who is stable, are they resilient, why. There are many, many questions that are intricately entwined with intervention strategies. So like the speakers before me said, there is still a way to go.
Questions from the audience? Going once? Going twice?
Everybody wants lunch.
Yeah, I don't know. So we'll see. Well, thanks a lot. Thanks very much.